Today I'll be going through my video demonstration for the SCADA Lab03. So first of all, I'll be going through my single element drum level control. So to give a basic overview, so we have our feed water and our feed water control valve, and so this goes into our boiler drum. Our drum level transmitter detects whether the feed water valve control valve should be on or off. And so in a single element drum level control, the water level in the drum is being measured. And so that is the only variable that affects this. So I'll go to my HMI. So this is my designed HMI for the single element. So we have our boiler drum here, which is connected to our feed water valve. So the feed water valve inlet is here. And we also have a feed water transmitter. So this detects the level and displays it back to our valve to turn on or off. I also have a graph to depict the drum level over time, and as well as this is our alarms that come up. So for this system and the next two, I use the variables of greater than 50, the level is high, and lower than 20, the level is low. And so this is in runtime mode right now. So if I hit 55, we'll see that the drum level is high and the feed water valve off. We also note that this has changed and we get the alarm there. This then goes back to 0, and then the drum level is low and the feed water valve is on. So this is the main functionality of my single element drum level control. So next we'll go through the 2-element drum level control. So this is the cascaded system where we have both level control and flow control, where level control is the primary control system source, and then the flow control is the secondary. And so we see here that the only difference is we still have our feed water going into our feed water control valve, but now we have our steam here that is connected to a flow transmitter. This is fed to a feed water flow computer, and we also have our drum level transmitter. So these two variables now affect whether the feed water control valve is on or off. So now I'll go to my designed HMI, which you can see here. And so in here, I have my boiler drum. So this all remains the same. So you have your feed water valve, your boiler drum, and then you have your steam here. So then you have your feed water level transmitter, which is connected to your boiler drum, but now it's connected also to a feed water flow computer. You have your flow transmitter from the steam also connected to this computer, which is connected to the valve. So that means that the steam flow and the boiler drum level affects the system. So using the same variables, I have 55 and we just input this here. So here, 55, our drum level is high, feed water valve is off, and so our outlet valve is on, so the steam is flowing. And so now we have a drum level low, our feed water valve is on, and our inlet valve is on, meaning that feed water is entering. So we also have a graph here that shows the displayed level, so you can see how this changes. And then you have our alarms here. And this is the basics of my 2-level drum level control. Okay, and next we'll go through the 3-level drum level control. 3-element, sorry. So in this case, we see here this dotted line. Everything to the left of this dotted line is the same as the 2-element drum level control. The only difference here is we have a feed water flow element and a new flow transmitter. So this remains the same. We have our feed water going in, but now it's going in through a feed water flow element. This goes to our valve, which goes to our boiler drum. We have the output of steam, and then we have our flow transmitter, the same as in the 2-element. We have our flow transmitter, our drum level transmitter. These go to our feed water flow computer. But we also have this flow transmitter, which is connected to this computer. And then this flow transmitter is connected to your feed water flow element. So now we have the steam flow rate is measured and used as a set point for the feed water flow controller. So depending on this, we have our set point. The feed water flow controller produce the necessary corrective signal to maintain our feed water flow at its set point by the adjustment of the feed water control valve. And so next I'll go through my design HMI, which you can see here. So this is essentially the same as the 2-element, but now we have an additional flow transmitter here connected to our feed water flow computer. This is connected to our feed water flow element. And so these three now affect the whether the feed water valve is on or off, and we also have a graph for the drum level over time. And then we also have our alarms. So just to show the basic functionality, say we have 55, our drum level is high, our feed water valve is off. And so that is how this works. This resets to 0, the drum level is low, the feed water valve is on. And so we see that his here, using the tags and control variables, we were able to successfully design 3 HMIs for this lab.